Hi guys, and welcome to Journeyman episode number 35. On this exciting episode, I'll make a two-step pulley for my Atlas horizontal mill. I started this in December of 2022. It is now October of 2023. A lot of life things going on, but I make the two-step pulley, and I also make a mandrel, tapered mandrel, to make this. If you want to see this long journey, stick around. I needed to make a fairly large pulley. So it was Christmas time and my wife had these cookie things. So I poured some aluminum in one of these. It needs to be 1.5 inches wide, and about 6.5 inches in diameter. Now the thing is it's very close on my pour because it was tilted a little bit. So hopefully I'll get the 1.25 out of it, but it's held in there very lightly right now, so I'm going to put a center in there, try to skim that off of there, get something to register, flip it around so I can hold it initially to get it machined. I tried something new when I poured this aluminum ingot. I didn't take the dross off of it. That turns out to be a mistake. Now my game plan is to get a couple of reference surfaces so that I can put this back into the four-jaw chuck with it being flat and square, and that will make the other part of the machining easier. Now one of the things I know I'm going to need is a tapered mandrel to do this correctly. So I decided to get on my Atlas 618 and make the tapered mandrel. Ever since I moved into our new home in Michigan and put back together the Atlas 618, something's not quite right in it and I need to take it apart and adjust it. Okay, having a little trouble cutting with this right now, and I'm going to switch gears. I'm going to come over here. Okay, I think I'm going to go ahead and make the mandrel over here on the south bend. But I started thinking, I was trying to get this thing round, and it is here. And I started thinking, I'm going to get this flat so I can flip it around. But then it started hitting me that all this machining means nothing if I mess up the middle. So why don't I go ahead and ream out the hole, make sure that it fits like it's supposed to, then make the mandrel and continue machining. So that's what I'm going to do. Several times with pulleys I've overshot the dimension, and so I'm making sure to really take my time, because if you make the bore too big, you've really messed your pulley up. And here I'm just checking to see what I think I'm cutting, I'm really cutting. But I hit right at 610. So this is, the lathe is cutting like it's supposed to. Alright, let's think about the final dimension now. There's a 625 shaft that's showing 624 on here. So 14 thousandths needs to come out. Yeah, that's 624. Alright. So about 5 thousandths to go. Well, I continued reaming until I got that hole reamed out and tested and all that. And I am pleased to say I lost the footage. Well, I didn't lose any footage. I didn't film it because it ran out of memory card. But now, here's what we got. Look how true that runs. I mean, beautiful, beautiful, snug fit. And this is the shaft it's going to run on. So it was running perfectly true on it. So I'm going to make a mandrel now and continue the machining. You know, on second thought, I think I'll clean up some of this stuff right in here, and then I will put it on the mandrel. I originally wanted to make the tapered mandrel here on my Atlas 618, but it wasn't cutting right, so over to the South Bend. Alright, I was very lucky. I'm trying to do the dimensions from Mr. Pete's video on one of these mandrels, and this diameter here is supposed to be 593 something, and I was just playing around. I thought it was half an inch, so 500, but it's actually 593, and I stopped it at 592, so I'm a thousandth under on that, so not horrible, but good thing I stopped when I did. Now it's time to get this one to length. I mean, get it down to like that. Well, look at this, ladies and germs. I got lucky. Found a already made a small little dead center, and it's running dead true. So let's put this in here. Just take a quick peek at it. Less than a thou. Alright, that's 750 and a half, and that's 750 and a half. But from this end to this end, you can see almost dead on. So I'm going to start machining away at it. Okay, I had to make took this drive dog and took the smaller one and connected it on there, but the screw on it was too long, so I went and got a grub screw. And so now I've got a drive system, and got to tighten that up a little bit, and we'll get to cutting. Okay, this looks like it's going to clear all the way to here. Okay, so that's clearing. So let's make our first pass. So let's see. This thing came loose. Got to tighten up my setting there. Now this type of lathe dog is meant for a faceplate, and I didn't have a Morris Taper 3 center, so I'm just kind of making do with it, and boy did that come to bite me. Well, I didn't mean for it to do it like this, but this might work. This is 695, and in the middle 694, and on the end 693. So it's tapering 0.02 from here to here. So we're kind of halfway home with that. Just have to do very little changing on here to get the perfect taper. So that lets me know I'm shooting a taper, but later on I'm gonna have to fix it. But I'm happy with that so far. Very happy. Okay, after further review, I did a spring pass on the way back, and it's actually not cutting a taper. So 677, 677, 677. So it's actually dead on true. When it goes that one way though, I don't know what it is, but it cuts a tapered, and on the way back it cleans that taper off. So still got to make a taper out of it, but this is cutting extremely well, cutting very well. Well, when I get stuck on one thing, I typically go to another thing while I'm thinking about how to fix it. So I went back to the 4-jaw chuck with the blank in it, and I think I got it smooth enough around the edges now and here to flip it over and do the other side. See what kind of metal we got on that side. Now you may have noticed the aluminum foil I have on the bed there, and I don't have any way protectors, so I put this aluminum foil down there to not only catch the chips and protect the ways, but also I'm going to take those aluminum shavings and melt them back down. Alright, now it's time to take a look at this baby, and it's going to turn out, this is going to work out nice. There's a lot more meat on this thickness. I've got about a 1/4 inch to go off, so that should clean up on both of those. Okay, the real reason I put the 4-jaw back on there is I wanted to recut these centers in here, make sure that they're perfectly true. So now I've centered that up in there, and now I'm going to cut. It's running nice and true. So let's do some cut. So I'm trying to get my mandrel size together, and to get this thing in here, I mean really a snug fit. It's funny because this is 624 thousandths. This is 627, so 3 thousandths different. And I'm telling you, it is snug as a bug in a rug, no slop whatsoever. So I'm trying to figure out what size to do the mandrel. And so I know it's got to be at least, to start getting in there, it's got to be under 627. So I'm going to say don't go too much. I'll start at 627 and go from there. I know you can't see that very well with the glare, but I am going to try to start my tapering, and I want the fat end here, the skinny end here. So I'm going to move this part that away. I'm going to start off by loosening this and this, and now trying to move this over by 2 thousandths. Okay, yeah, I'll put it at 2 thou. Alright, now let's do some machining and see what happens. Okay, so what we have here, let's see, 633, and then 638, so a 5 thousandths taper. I was looking for 3, so that may not be horrible. Let's do this. Let's take it down again, try to smooth it out a little bit, and try it again. Okay, after a couple of more light passes and moving that, it was too much, so I moved it back a thou. It's 28, 30, 31. So from 28 to 31, 3 thousandths like we want. Okay, so now it's just a couple of thou I have to take off of there to get it to, probably want to get it to 20, a little under 25. So let's see, do I want to take the full 3 thou? So 3 thousandths. Let's do it. Well, now does it work? Let's see. Oh, it does. Okay. It goes through there and starts getting tight. So now I'll go press that on there and start doing some machining. Alright, let's see what we got, ladies and germs. Alright, let's do some machining. Now, much of this video is sped up. And speaking of speed, there I was. From 1992 to 1994, I flew both for the military and the airlines. Well, I got the 2 steps marked out here, and so now I'm going to clean off that, get rid of some of this diameter. Okay, 2 things. One is I'm going to change tools because that throws stuff all over the place. But one of the things I forgot to do is reset this. So this is on a slight taper. So I'm going to reset this again back to cutting, not a taper, and then continue. Okay, got that squared away. And now let's do some more machining. I spent my active duty military time flying the F-16. When I got out of the military, I went and started flying the 737 for United Airlines. And also at the same time, I got hired by the Michigan Air National Guard flying the F-16A model. So one of our airplanes was left at Wright-Patterson Air Force Base, and I was tasked to go get it and bring it back to Selfridge. So en route to Selfridge, I wanted an altitude change of about 5,000 feet. The higher you fly, the more fuel efficient the jet is. Thanks. I requested that altitude change. The air traffic controller asked me if I could be there in 5 minutes or less. You're killing me, Smalls. You're killing me. So when he asked me if I could be there in 5 minutes or less, I told him I can be there in 5 seconds or less. So this is pretty good on this side here. And now I'm going to try to get off. This was the top of it, so all the air bubbles. So I'm going to flip it off and start facing this off. We still got a good 1/4 of an inch that needs to come off of there, so hopefully that 1/4 of an inch will go below that that porosity. Now, if I'm remembering correctly, the air traffic control center that I was talking to was Cleveland Center, and they must not have been used to dealing with fighter aircraft. But since I said I could get there in less than 5 minutes, he cleared me to the new altitude. So I lit the afterburner and pointed it toward the moon. On the top part of that pour, there's still a couple of pores, so I'm gonna, the other side's nice, but this was the top part of the mold and there's still some pores. I'm getting almost down to thickness. So what I think I'm going to do is make the big pulley on this side, because a lot of the pores are in the middle and that's going to get gouged out anyway. The other side has nice and beautiful, so I'll leave that be the 4.5 inch pulley, and on this side it'll be the 6.5 inch pulley. So hopefully that works out. There's been a lot of machining on this, and I don't want to do it in vain. Okay, about 25 thousandths needs to come off of that, so we'll take 25 more off, and we'll start turning it into a pulley. Now the air traffic controller told me to call level at the new altitude, and a couple seconds later I told him I was level. So here's what I'm thinking. Outside of that, where the pulley part is going to be good. I'll be gouging that out, and that too. So hopefully I'm going to use this as my 6.5 inch side. This is going to be my 4-inch side. So I'm going to take this and take it down to the 4.5 inches right now. Alright, so I put some numbers on both sides of here just to give me some references. I'm going to start getting that 4-inch pulley down to diameter now, but I needed to know about how far to go down, so we'll start whittling away at that. So back to my F-16 speed story. Now most time we talk about speed, we're talking about horizontal speed, but in this case I'm talking about a vertical speed. Now in the F-16 we have a vertical speed indicator not only in the HUD, but we also have a round dial, and it pegs out at 10,000 feet per minute up and 10,000 feet per minute down. Now routinely in the F-16, if we were going to be climbing, doing maneuvers, we would peg that thing up either 10,000 feet up or down. It was amazing, the vertical speed. Okay, this is at 665, needs to be at 25, so 40 thousandths needs to come out of that. So 40 thousandths, so I'm going to take off 30, and then we'll start working with the diameters. Boy, we're getting close. So when I told the air traffic controller that I was level at the new altitude, it totally caught him off guard. All he could say was, "Whoa, that was impressive. You beat the sweep of my radar." Now what the air traffic controller didn't realize was the climbing part wasn't the hardest part. The hardest part was arresting that type of climb rate and leveling off when I was supposed to and not breaking through that altitude. How about that, boys and girls? Alright, so we're going to color that one good and work on this one now. Work on the smaller diameter. Okay, so what I did is I touched off right here, and this to come to dimension needs to be about 8.5 thousandths more off of there. So I've got that zeroed, so I'll face that down to where it is the final dimension, and once that hits 0, I'll go in the 8.5 thousandths, and then I'll face it out, and all these dimensions should be 2-dimension. Okay, final cut. Got it all measured up. This should be 10 thousandths to take it to its final dimension, and then we're going to touch that and go 8 thousandths, and let's do this thing. About 2 thousandths too thick. That's excellent. I think we'll call that good. Alright, now to start cutting the V-grooves. We got a little challenge here with, I can't get this quite square, this tool that I'm using. And so I'm going to go at a slightly different, I'm going to slightly go at an angle. I like to bottom it out, but I'll have to dig down in there first before I can get that thing square in there. So let's do that. This drive dog setup keeps causing me some trouble. Let's try it again. And since I was having trouble cutting, I wanted to square up the tool, so I went to the little pulley, stuck it in back here to slow it down, and that did help start the cutting. Now this is crazy. I put permanent Loctite on there, and sure enough, it broke that seal. Try it again. Put some more red Loctite on it. I need a better drive dog is what I need. Well, I'm going to need to redo that lathe dog with the red Loctite. So what I'm going to do here is just do something with less cutting forces and take this thing down. That's not supposed to be on there. So I'll just take it down, and I'll Loctite that, and we'll do it tomorrow. Well, I'm trying a different tool just to see if that'll help a little bit. Really chattering on me, so I try different tools, different tool angles, and different speeds to try to stop the chatter. Alright, I flipped this thing around, and I'm just going to take off this side now. I'm not all the way down on that part, but just getting it roughed in. Removing material. Well, that's starting to look like a pulley. Okay, I'm a little stuck on this one. I have to work out some geometry to get more off. So now I'll concentrate on this one for a little bit. Start at least hogging out the middle stuff. Alright, I got that a little roughed out there. So now move the tool out a little bit. Now I'm going to work on this one again. Okay, this is a different tool I have in there. It sticks out a little further, and I think I can get to the correct depth. Now, I have this set on, let's see, 19 degrees. Now, the reason I did that, on the drawing here, it shows it at 38 degrees on the big pulley and 36 on the small. So, since that's an included angle, I put that on 19. And then when I go to that one, I'll switch it 1 degree to 18. I don't know if that makes a huge difference, but I'm going to try to go as, as close to the drawing as I can. So I wasn't able to get in there close enough with this tool. Just didn't go deep enough. So I pulled out another pre-ground one from a flea market. Let's see if I can get this done. Once I got close to my dimensions, I checked the belt in there and it fit perfectly. And so now it's time to hit the dimensions on the smaller pulley. Now, because of the dimensions of these pulleys and the geometry, I had to keep flipping it around so that I could get the tool in there and make the cuts. Well, I had planned on keeping this little thing for at the end, holding on to it to machine this other side flat. That little nub on that side, but I think I'm going to go ahead and take that off of there right now so I can start machining the contours in here. Just watching another guy's video, he took a 15-degree angle into there, and that looked pretty good, so I think I'm going to do the same thing. Alright, well, I've taken it off the mandrel because now all the concentric stuff is done. However, I need to face that off of there and take some metal out of here. Also, I need to take some more metal out of here and face this here to the right. Even with this, there's some of that pores left in there, some pores. So what I'm going to do is mix up a little JB Weld and fill that up tonight. And I think there's one spot down in here. Yeah, I'm going to do that too. Get that JB welded, and then when I machine it tomorrow, hopefully it'll look a lot more better. So here's our freshly JB welded and dried pulley. And again, this pulley is supposed to be, that's supposed to be flush right there. However, this looks almost like the perfect spacing on the machine. Let me show you what I mean. So when we look at how this lines up on the shaft here, it's almost like a perfect bushing when you can see that lines up by just pulling this out, the top just a little bit, they're lined up. So I think what I'll do is just face that off a little bit and leave it a little like that. Okay, I think I'm going to take it back there maybe another 1/8 inch and just kind of clean this up to just make it pretty. That's all I'm doing right now is beautifying it. Well, that's the profile I'm going to go with. And now I'm going to just polish it up a little bit before I take it off and spin it around. Okay, so this is what we have. I think it looks great. And now, you know, there's that pores in there, but we expected that. I may be doing a little bit of JB welding in there, but wow, I think that turned out wonderful. Now I need to take this side and remove that and put a little, like I've got that little indentation here. I'm going to do a little bit of an indentation there and take off that. So let's finish that up. Okay, I have to say, guys, that turned out phenomenal. That really turned out nice. Beautiful looking pulley. Still got the little voids in the back there, or in the front, but anyway, put a set screw in there, we'll call this thing done. And here's its new home. Set screw set. Yeah, that's nice, guys. Alright, let's get it rolling. Now the small two-step pulley that you see on there, it was wiggling so much I had to rebush it. And that'll be in another video. So the low speed pulley works great, so let's give the high speed pulley a try for the very first time. It's vibrating so badly that I think something's wrong with the machine. Guys, I am shocked at the shaking of this machine. If I don't have both hands on it, it'll shake itself apart. Now this is with no hands after I balanced it, and it sounds louder than it really is. I just had to know how much aluminum I could recover from the shavings on making this pulley, and I was pleasantly surprised. So here's the new two-step pulley, and that's all the shavings that I melted down. That's quite a bit of aluminum I got out of those shavings. Okay guys, I'd like to share a couple of lessons learned on this. Number one, it's better to start off with nice clean aluminum. I left some of the dross on there, and it looked like it came back to bite me because of the porosity in there. Number two, when the blueprint says must be balanced and tested, I didn't think it did, but it needs to be balanced and tested on this pulley. And so I learned some things in here. Also, I'm going to do a totally separate balancing video because it's just too long to put on this one. But wow, I did a couple of methods on balancing a pulley, and if you want to see that, you can see that on one of my next upcoming Journey to Journeymans. Also on that tapered pulley, tapered mandrel that is, what a cool thing to make. I didn't hit the dimensions perfectly, but it worked out really well. So next time, hopefully I can get those as directed. Well, I hope you enjoyed this episode. I thank you for watching, and I hope to see you next time on Journey to Journeyman.